Alright, this is the homework assignment from the packet on trying to prove identities. And one of the things that we talked about is one of the first things we want to do is we want to try to write all functions in terms of sines or cosines. So I'm going to change that cosecant, which will be my first step. 1 over sine, 1 minus sine theta. Cosecant becomes 1 over sine theta, and all this is equal to cosine squared theta. And then what I'm going to do is a little bit of algebra here, just state change flip. 1 minus sine theta. Division becomes multiplication. 1 over sine theta flips to sine theta. Is cosine squared theta. Simplifying. We get 1 minus sine squared theta is equal to cosine squared theta. And then you have Pythagorean's theorem, or Pythagorean's identity, which changes the 1 to sine squared plus cosine squared. So using identity and substituting that in, that's my 1. And then continuing, minus sine squared is equal to cosine squared. And then on the left hand side, simplifying, the two sine squared thetas will cancel, leaving me with cosine squared theta is equal to cosine squared theta, and we're done. Next one, page 488, number 11. Before I change this one, all I'm going to do is distribute the cosine through. So I'm going to take care of that and that. And so that's cosine theta, secant theta, minus cosine squared theta is equal to sine squared theta. I'm then changing secant in terms of sines and cosines. That's going to be 1 over cosine minus cosine squared theta is equal to sine squared theta. And what happens is, multiplying these two things, the cosines will cancel, leaving me with 1 minus cosine squared theta is equal to sine squared theta. And once again, 1 becomes sine squared theta plus cosine squared theta, then minus cosine squared theta is equal to sine squared theta. I'll be able to get rid of the two cosines, leaving me with sine squared theta is equal to sine squared theta, and we are done. The next question, which is 488, number 13. Alright, changing things to sines and cosines again. We got cotangent, which is going to be cosine theta over sine theta. And then that's going to be divided by cosecant, which is 1 over sine theta. And all of this is supposed to equal cosine theta. And as we talked about in class, what we should be doing, and I should have been doing it with the other questions, is supposed to be freezing one side of a problem. And let's always keep focused on what we're trying to prove. Here's the original question. I'm going to show that cotangent theta over cosecant theta is cosine theta. So we make those changes, trying to simplify the left hand side. We're going to get cosine theta over sine theta. That fraction stays. Division changes the multiplication, and then the bottom fraction is going to flip, and all that's supposed to be cosine theta. And then some simplification, canceling those out, we get cosine theta is equal to cosine theta, and we're proven. Okay. Question 488, page 48, number 15. Once again, highlight that so you know what the original problem was, and what we're trying to do in this question again is show that secant theta over cosecant theta is tangent. So let's change everything that we can on this side, freezing the tangent, everything on this side to sines and cosines. Secant is 1 over cosine theta. Cosecant is 1 over sine theta. And this is supposed to equal tan theta. Simplifying by doing this division, the top fraction stays, division changes the multiplication, and that bottom fraction flips. Doing the multiplication, that's going to be sine times 1, which is sine, and cosine times 1, which is cosine, and that's supposed to equal tangent theta, and then sine over cosine we know is tangent of theta, and once again, proven. Okay, next question. We're going to jump to was it 15? So we're going to jump to page 488, number 17. See if I can get that one centered. There we go. All right. We will use the highlighter to make sure we're good here, so we understand where we started. So we're starting with this 1 over sine cosine minus sine over cosine is equal to cotangent. So we're trying to prove that. So we'll freeze this side. This is first problem that's a little bit more unique because everything on the left hand side is in terms of sines and cosines. So what we're going to do is, you notice we have 2 terms, and we're trying to make it one term. So I'm going to actually do that subtraction. So to do the subtraction, we need to put those 2 fractions together by coming up with a common denominator, and that common denominator is going to be sine of theta times cosine of theta. And notice that this denominator didn't change, so its numerator is going to stay the same. This denominator was multiplied by sine, so I have to multiply the top by sine, giving me sine squared theta. And all that's supposed to equal cotangent of theta. And again, I'm going to look at that 1, and I'm going to use Pythagorean's identity, which is sine squared theta plus cosine squared theta, and then finishing it minus sine squared theta. All that's over sine theta, cosine theta, and that's supposed to equal cotangent of theta. When I take a look at what's happening up top, I have the 2 sine squareds that will go away, and now that's leaving me with cosine squared theta divided by sine theta cosine theta, and that's supposed to equal cotangent of theta. And simplifying again, those 2 will cancel, leaving me with cosine theta over sine theta, and that's supposed to equal cotangent of theta. And we're supposed to know that cosine over sine is cotangent, and we're done. Next question, page 488. Again, things are in terms of sines and cosines. But one thing that we're supposed to realize is you have the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And if you're in a jam, we kind of are right now, you have that cosine squared. So if you use Pythagorean's identity and you solve for cosine squared by subtracting sine squared from both sides, we get cosine squared theta is equal to 1 minus sine squared theta. And that's what we're going to use. I'm going to use that little piece right there to help me with the rest of this problem. So I'm going to take 1 minus sine squared theta and put it in for cosine squared theta. So here we go. 1 minus sine squared theta over 1 plus sine of theta is equal to 1 minus sine of theta. And then I can't cancel these things. They're attached to one another with plus or minus, so you can't cross cancel. So what I'm going to do is I'm going to realize, or look, this is real important that you see this, that this is the difference of 2 perfect squares. So I'm going to factor this. When you're factoring the difference of 2 perfect squares, it's 1 plus sine of theta and 1 minus sine of theta. And that's going to be all over 1 plus sine of theta, and that's going to equal 1 minus sine of theta. And then once you factor, you can see that you have a factor on the top and in the bottom that is exactly the same. That's the time when you can cross them out, leaving me with 1 minus sine theta is equal to 1 minus sine theta, and we're done.